Okay, this is page 33. Page 33. Follow along. Notice the title, Proportional and Non-Proportional Relationships. Proportional and non-proportional relationships. So you can write in there with me. It's at a pizza party. Miss Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Number 1, complete the table to determine the cost for different numbers of pizzas ordered. Well, let's see. If she orders one pizza, it's going to cost $8. So if you order 2 pizzas, that would make it $16. 3 pizzas would be, what, 24? 4 pizzas would be $32. 5 pizzas would be, what would that be? 40. All right, do you notice that all we're doing is we're multiplying 8 times 1, 8 times 2, 8 times 3, 8 times 4. Okay, these are all equal fractions. If you notice that, if this is a fraction, they are all equal. We're just scaling up is all we're doing. Okay, look down to the next. It says, for each number of pizzas, fill in the boxes to write the relationship of the cost and number of pizzas as a ratio in simplest form. See, we're comparing cost and pizzas. Cost and pizzas. So we just want to reduce these fractions. So let's see. We have 16 over 2. Well, that's the same as 8 over 1 if you reduce it. On this one, 24 over 3. If I reduce that, doesn't it reduce to, what goes in both those? 3. 3 goes in there 8. 3 goes in there 1. Okay, what about the next one? 32. Let's see. 32, there was 4 of them. Excuse me. 32, there was 4 of them. So 32 over 4 is the same thing as, let's see, 4 goes in here once, 4 goes in there 8. All right, what about for 5 pizzas? For 5 pizzas, it was $40. Okay, and if I reduce that, 5 goes in here once, 5 goes in there 8 times. So, what do you notice about all these ratios? What do you notice about all these ratios when you simplify it? They are all the same. I'm just going to say same. But what's another word we use for same? I'm going to use capital letters here. Equivalent. They are all equivalent ratios. Right? These all come out to be the same answer. They are equivalent. And notice how these are all equal fractions. As a matter of fact, these are proportional. These are proportional. If I just take 2 fractions right here, they make, if I put equals, see that? They make a proportion. They're all proportional. So today we'll do notes on proportional relationship with tables. Proportional relationship with tables. Next time we'll use it with graphs. So today we'll do notes on proportional relationship with tables. Proportional relationship with tables. Next time we'll use it with graphs. Another thing to note is that if I take 8 divided by 1, I get 8. 16 divided by 2 is 8. 24 divided by 3 is 8. See that if I divide each one of these, they are the same number. So each ratio is the same. That's also a way of determining if it is proportional. Okay, so let's define what proportional relationship means. Proportional. Proportional relationship means, this is what it is, that the rate now I'm going to put in the rate, or ratio I'm going to say rates. The rates are equivalent. That's what it means. They are equivalent. The rates or the ratios are equivalent. Now, this isn't really a formal definition. This is kind of like my definition, but it makes the most sense to me. And I'll explain why. So we'll put that same example that we did in our notes, because all you need is really one good example. So we have dollars in pizza. That's supposed to be a Z right there. P-I-Z-Z-A. Pizza. Pizza. And we know that for, I'll just do this. And we know that for every one pizza, it costs $8. For 2 pizzas, it costs $16. 3 pizzas, what was that, 24? I'll do one more. Right? So this is telling us how much it costs for each pizza, or how many pizzas. Now notice when you have 1 in the denominator, like this one here, there's a name for that. Do you remember? This one right here. Right? That's called the unit rate. Okay, that will come into play later. Okay, so how do we see if something is proportional? Well, one way to check if proportional P-O-R-O, port, I-O-N-A-L. One way to check if proportional is to divide. Each ratio. All right, so that's how you can check to see if it's proportional. Just go ahead and you can divide. That's one way of doing it. So for example, this one right here, you have, I'll just put this here, you have 8 divided by 1, right? 8 divided by 1 is just 8. What about the next one here? 16 divided by 2. Well, 16 divided by 2 is 8. The next one, 24 divided by 3. If you divide that, that's 8. So do you see they're all the same? And the other one, 32 divided by 4, that is also 8. Notice they are all the same. I'm going to box those in just to show they're the same. right? Okay, almost done, just one sentence. If they simplify to, darn it, that's why I hate writing in pen. I got to use a whiteout if I make a mistake. So if they simplify to the same value, same answer, then the relationship IONSHIP is proportional. So that's how you check. All we do is we just divide. That's one way to check. That's one way. Okay, so if you're given some data like this, if you divide each one of those and they come out to the same answer, guess what? It's proportional. What if they are not the same? Then it's not proportional.